All right, people, what's happening? Today we're working on, it's over here. Let's see. Yeah, right here. Lesson 3-6. We are cruising through chapter 3. Going to do one of my all time favorite things to do. That's right, sequences. In particular, guys, we have two different kinds of sequences we learn about this year. Geometric sequences we will learn about later. Today it's all about these right here. These are called arithmetic sequences. Some people might call them arithmetic. Who really cares? Okay. So let's go over a couple things. First off, a sequence, guys. What is it? It is just a series of numbers, right? Just a series of numbers, right? Maybe they have a pattern. Maybe they don't have a pattern, right? Just a sequence is just a series of numbers, right? When we talk about terms of the sequence, right? We have special. You're gonna love today's special notation stuff, right? We'll call the first term, guys. The first term we call A1, right? So when you see A1, just know that it's talking about the first term, okay? If we were to see something like A10, right? Well, that's talking about the 10th term, right? If we saw something that said, A22, that's talking about the 22nd term, okay? All right, so terms of the sequence. As mentioned, an arithmetic sequence, guys, these are our ones we're going to do today. So these sequences will always go, so again, it's a sequence, it's a series of numbers, and because they're arithmetic, they will always go up or down by some number, right? By some number. They could go up by 5, they could go down by 2, they could go up by a half, they could go down by 4, okay? Who's to say, okay? That's what an arithmetic sequences are. I'm sure you guys have seen these before. They're like, hey, find the next two numbers in this sequence, right? And you got to, oh yeah, they're just adding two or whatever. Common difference, that's what our arithmetic sequences have. That's what makes them arithmetic. A common difference, guys, we will represent with the letter D. We have a very special formula that we will get into later that we use. But yeah, there we go. So there's a little bit of everything that we're going to do today. Let's carry on and see what else we can figure out here. We got to be a mouse. Come on. Oh no. Oh no. We got technical difficulties. Hold on. I think the cord came loose. We'll figure this out. Okay. Hopefully it's working. Who's to say? Really? Okay. Oh, beautiful. There we go. Okay. Arithmetic. Look, I just told you all of this stuff. You guys know this, right? Here's your very fancy definition. It's a numerical pattern that increases or decreases at a constant rate, right? So again, sequence, series of numbers, numerical pattern, right? Goes up or down at a constant rate. So some of the easier tasks we'll have to do is just figuring out, is this an arithmetic sequence? So guys, all we really need to do is look at these four terms here and see if they're going up or going down by the same amount. So on this one, it would appear what's happening here. How am I going from negative 15 to negative 13? Well, it's increasing by 2. So is this an arithmetic sequence? We would say yes. Explain. Well, the pattern on this one is it's increasing by 2, right? You would just say it has a common difference of 2. All right, so you can write all that down. I'm just going to talk through it. Okay. Determine whether, again, 7/8, 5/8, 1/8, negative 5/8 is an arithmetic sequence, right? So again, first two terms here, right? If you're not sure what the common difference is, we call it a common difference, we subtract. So guys, if we subtract these numbers, right? Okay, so it looks like we're going down by 2/8, or really 1/4, okay? Between the first term, A1, and the second term, A2. If we look at our second term to our third term, so now we're going from 5/8 to 1/8. So this is going down by 1/2. This is not an arithmetic sequence. We need the common difference to be common through every term, not just one or two of them. So the instant that we find two different common differences, right? Here we had 1/4. Here we had 1/2. we can stop and say, no, we don't have a common difference here, and this is not an arithmetic sequence. Okay? Same thing here. Determine whether 2, 4, 8, 10, 12, blah, 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 is an arithmetic sequence, right? So 2 to 4 looks like we're going up by, I'm going to say 2. 4 to 8, we went up by 4. Here we're going up by 2. Here we're going up by 2. So a lot of those are increasing by 2. But once again, all it takes is one term. When I go from the second term to the third term, it goes up by 4. That cannot happen. All of these have to be the same common difference, okay? So is this an arithmetic sequence? Absolutely not. Alrighty? How about this one? 2/3 to 1, 4/3, 5/3, 2. Okay? So again, do a little bit of subtraction. 1 minus 2/3, or 4/3 minus 1, or 5/3 minus 4/3, or 2 minus 5/3. We keep getting that same number, right? 1/3. So yes, unfortunately, we will have to deal with fractions sometimes in our sequences, right? That's okay. This one's good. So is this one arithmetic? Absolutely. Absolutely it is. It has a common difference of 1/3. Ah, yes. Finally, we can do a little bit of math here. Find the next 3 terms. All right, so first thing we had to do, is it arithmetic? Yes or no? Do some explaining. Not a big deal. Next thing we're going to do, hey, just find the next couple terms for me, right? So recognize the pattern. Looks like the pattern here, we're going down by 3. So if that pattern continues, I'm going to assume -20, -23, and -26 are going to be our next 3 terms. Literally nothing more to do than that, okay? All right. How about this one? Find the next 3 terms here. Well, again, first off, we can't find the next 3 terms if we don't have that constant number that we're going up or going down by. So here I'm going from 58 to 63. I think that's about 5. Looks like another 5. Looks like another 5. So yes, this one would say have a common difference of 5. Okay? And if we're going to give you the next 3 terms, what do you guys think? I'm going to go 78, 83, 88. What do you guys think? You agree with me? Well, you should, because that's the right answer. Okay. All right, so that's the easy stuff. Now we get to do some fun stuff. Okay. What is going on here? Okay, let's talk real quickly about this formula here. Maybe I can zoom in. We were on it there. Okay, beautiful. Okay, so guys, I'll read it for you first. So this says, this right here, guys, we call it the nth term. So the nth term, right, is equal to, and then this right here, we got lots of variables here. A1, first term, plus, and then we have this n minus 1, right, this quantity n minus 1, and we're going to multiply it by d. Remember, d is the common difference. And guys, n just represents whatever term number we're trying to find. So if we were trying to find the 100th term, right, I would plug a 100 in here for that number. If we were trying to find the 28th term, I'm going to plug in a 28 here. So guys, what we're going to do is we're going to make, we call this an explicit formula so that we can find any term, right? Because typically they're not going to say, hey, find the next 3 terms. They're going to say, hey, find the 1,000th term, or find the 500th term, or find the 99th term. And it would be annoyingly frustrating to, like on that last problem, right? When we had 88, and then, okay, yeah, we're going to go to 93, and then 98. Keep counting all of those until we got to the 100th term. That would be ridiculous, okay? So, of course, they made a formula for it, and here's what it looks like, okay? Yeah, I'm good with all this. All right, let's see what else we got here. Ooh, whoa. All right, we can maybe go one more. There we are. So write an equation for the nth term. Bam, here's my sequence. Well, let's double check first off to see, is it really a sequence, right? So the first thing we need to do is find our common difference, right? Which we represent with the letter D. So to do that, guys, we're just going to take the second term, 10, subtract the first term, 1. That's 9. 19 minus 10. 28 minus 9. Doesn't matter. I keep getting 9 for this, okay? So my common difference is 9. And that is all I need to know to make my formula work, okay? So write an equation. So, oops, here we go. All right, so AN equals A1 plus, you know what, guys? I'm kind of a loser. I like my D here in front. It doesn't change the meaning, right? I know the formula writes it over here. What are we going to do first? We're still going to distribute, okay, is really what it comes down to. Okay, so we're going to find an nth term formula. A1, guys, what was the first term of this sequence? Right? Again, if we're going to use a formula, write it out, plug in what we know. So A1 is the number 1. My common difference, that's what I found, right? We take second term minus first term, third term minus second term. That was a 9. N minus 1, guys, just stays as n minus 1. We want that n left in there. Okay? Sorry, equals a to the n. All right, so we're going to distribute and combine like terms. It's going to look like this. 1 plus 9n minus 9. Awesome. Combine your like terms, right? So now we can say, hey, n, or the nth term, is equal to 9n, and then I'm going to combine these two right here, and we're going to say minus 8. Okay? So now, guys, I can use this formula right here. It's like I'm holding it. I can use this formula to find any term that we want. So we know the first 4 terms of this sequence. They gave them to us. But if they said, hey, find the 99th term, now I can do that with this handy formula, right? 9n minus 8. Okay. And of course, look, they want me to find the 12th term. All right, so here's how this works, folks. Let me get rid of some of this stuff here. So 9n minus 8. Here, I can just remember that. Okay. an equals 9n minus 8. All right, so here's how this works. And it could be the 12th, the 112th, the 212th. We have to have this first, okay? And then we can say, hey, a of 12, right? Because this is the 12th term, right? Now look, this is interesting. So n turns into 12. If I want to find the 12th term, guys, n also over here turns into 12. Oh, it looks just like that. Now I have to do some brain power math. So the 12th term is equal to 9 times 12. So that's, 90 and 18, 108 minus 8. If I'm wrong, we're all bad. So then we'll subtract those and we will say, hey, the 12th term in this sequence happens to be the number 100. Pretty useful, okay? Again, all we did, replace n with whatever term they want me to find. So the 12th term in this sequence turns out to be 100. Okay? Fantastic. Graph the first 5 terms. We're not going to graph these things very often. They're super easy to graph, guys. If you look over here, again, here's the first 5 terms, 1, 10, 19, 20, 8, 37. When we graph them, the term number, the actual number that term is your y value. And just whatever the term is, so the first term, the second term, the third term, that's your x value, okay? You can kind of think of it as, here's all of your inputs, right? Here's all of your outputs, all right? So there they could be graphed. Ooh. And then these are the sneaky ones. So remember, we had our an equals 9n minus 8, right? This was our, hey, find me the 12th term, whatever it is. But now, look, they want me to know which term of the sequence is 172. So which term, like basically, like is that the 18th term or the 19th term? I don't know. But here's what we can do. Because we have our formula, remember, n represents the term number. So if they're saying, hey, if this is 172 or equals 172, solve for n. So I'm literally just going to replace this with that value, 172. Okay? Now I'm going to solve my equation for n. And when I do this, right, we will know what n is equal to. In this case, let's see, we're going to add 8 to both sides. This turns out to be 180. Right, divide by 9, divide by 9. N equals, I think that should turn out to be 20. Bam, I solved that really quick. So here's what that tells me. So this tells me the 20th term, right? The 20th term of this sequence is 172. So we can use our formula either way to find a specific term number, right? Like, hey, find the 12th term, find the 33rd term. Or if we have this, they can say, hey, figure out what term is equal to 1008. And then literally, guys, all we do is plug it in to our formula, solve for our variable n, and we're good. That was quite enjoyable. I hope you like that. All right. So here's another sequence, right? 2, 7, 12, 17, 22 represents the total number of pencils Claire has. Write an equation for the nth term of the sequence. So again, for starters, make sure this really is a sequence, folks. At some point in time, they're going to try to give us a sequence that isn't a sequence, right? We don't want to do all this work for nothing. So 7 minus 2 is 5, 12 minus 7, 5. Okay, yeah, we keep subtracting 5, right? Or getting 5 when we subtract our terms. So write an equation. Okay, here we go. So remember, if we're going to use a formula, right, just write it out. N minus 1. I'm using capital letters. Really shouldn't do that, but it's okay. It's, it's just me. All right, so the nth term equal to A1 is 2, right? My common difference was 5. This expression, guys, n minus 1, basically what does this do for us? Well, this makes us go back to like the start of the sequence for us. That's why we do this, okay? Again, we don't have to go over the intricacies of the formula. Just trust it, okay? Let's combine some like terms here, and we're going to get the nth term of this sequence is equal to 5n minus 3. Okay? 5n minus 3. Bam, there it is right there. So again, I can figure out any term number, right, that you're going to give me. Hey, find the 28th term. Or I could figure out, hey, if the number 482, figure out what term that represents. So anyway, do we need to do anything with 5n minus 3? Yes, find the 12th term of the sequence. Okay. So 5n minus 3, right, is my nth term formula. So replace n with 12. So the 12th term is going to be equal to 5 times 12. Oops, I wanted to put plus 3, but it really shouldn't be. It should be minus 3. Okay? All right, so let's say that this is what, 60 minus 3. So the 12th term, A sub 12, right? That's the 12th term is 57. Right? Much quicker, guys, than if we were to keep adding or subtracting that number. Now this one 12 times, not that bad. We could probably do that, and it wouldn't be awful. But if they said 112, there is no way we would want to do that. You know what I mean? Here we go. So once again, they're asking me to figure out which term of the sequence is 97, right? All right. So 97 is going to be a number in our sequence. Let's figure out which term it is. All right, so again, we're going to use this formula. Now this turns into 97 equals 5n minus 3. Okay. So again, we're going to solve this equation. We're going to add 3 to both sides. This turns out to be 100. Divide by 5, divide by 5. N equals, I believe it should be 20. So the 20th term of this sequence, right, is this 97 number. Great. You guys enjoying this so far? Yeah, it's not too bad. Pretty good. All right. Write a function for this sequence. Okay, 12, 23, 34, 45. All right, so first off, do we have a sequence here? So 23 minus 12, I'm assuming that's 11. 34, okay, there's another 11. 45 minus that one. Okay, so yes, we have a common difference of 11. So we can write a function for this sequence, okay? And again, here's what we do, folks. If you're going to use a formula, write it out, dn minus 1. Plug in what we know. Again, n minus 1, this part over here always stays there, okay? The first term of the sequence. Look, I don't even remember what it was. Can we go back to it here real quick? 12. There we go. All right, so my first term is 12. My common difference was 11. I do remember that. And then n minus 1. Okay? All right. 12 plus, this should be 11n minus 11. We can combine our like terms here. So 11n, 12 minus 11, just 1. Okay? And here we go. So this is, right, this is our explicit formula for this sequence, right? 11n plus 1. Yeah, let's maybe we get to do some more stuff with this. Graph the function and determine the domain. I'm sure we could graph it, guys. I don't really, again, it doesn't say, does it tell me how many terms to graph? It sure doesn't, okay? Again, the first term on this one, right, we figured out was 12, second term 23, third term 34, fourth term 45. Those are going to be your ordered pairs. So 1, comma 12, 2, comma 23, 3, comma 34, 4, comma 45. Those are your 4 points to graph. Determine the domain. Well, the domain, guys, is just the term numbers. So the domain has to start at 1, and then in theory, this sequence goes on to infinity. But we're really only including whole numbers, right? Because is 1.5 in the domain of this arithmetic sequence? No, because we are only finding like whole number terms, like the first term, the second term, the third term. There aren't half terms in this sequence or any other, fractional piece as well, okay? So the domain, we would just say, is all, in this case, natural numbers, because natural numbers start at 1 and go 2, 3, 4, 5, 6, 7, 8, 9, all the way on to infinity. Okay? So that would be our graph. Again, you guys can make your own graph there. Again, I gave you the ordered pairs. The domain of it, guys, again, is just all the natural numbers. Okay? Yes. Write a function to represent this sequence. Okay, so once again, do we have a sequence here? 22 to 40. Okay, that's 18. Okay, 18 again. Yes, we do. Okay? So write a function for this one. Why do I always scroll up too much? There we go. Okay. So the nth term is equal to a1 plus d n minus 1. That formula hasn't changed. Hopefully you're getting very comfortable with using it. All right, the first term is 22. The common difference is 18, also known as the best number in the world. We'll distribute that 18. It's going to look just like this. And then we're going to combine our like terms, and we're all done. So this is going to be 18n plus 4. And we're all good. Now we can do anything that you would like me to with that. We could find the 99th term. We could find the 1000th term. We could tell you what term number is equal to some specific number in our sequence as well. Okay? And guys, I think that's going to just about wrap it up for today. Yeah, we're at the end. So arithmetic sequences, hopefully you enjoyed this and it was helpful. If you have questions, let me know. Otherwise, we can move on to the rest of our fun stuff for arithmetic sequences. Have a great day.